ரிஜிஸ்டர் நம்பர் இதானே?
நான் ஏதோ பார்த்தேன்னா உங்க வாட்ஸ்அப்ல இருந்து.
Am I audible to you all? Please respond to me. இத கொடியில போட்டுருங்க. Shall we start? Hello. Can we start? May I know who are all in the line? I'm audible to you all. Please respond. Hello, am I audible to you all? Can you respond? Hello, shall we start? Shall we start? May I know who is online? Bhagya Raju. Only you are there? No one's joined? Hello? Hello? Okay, if you people want me to explain something, we'll start the class. Let us start. Let us start. Okay. Now we are going to see the lesson that is on air pollution sampling and measurements. So when we are studying about the air pollution and air pollutant, we must know that how we can know or we come to know what pollutant is there and how much pollutant is there. That is very important. And the doing of air sampling is not that much easy. There is a described specialized method is available for doing this air sampling. It is not like a water sampling. You would have done water analysis, and they would have asked you to get the water from your own bore water and sewage water, something like you would have brought, I think so. So how did you do the sampling? Simply would have gone, you would have had some sampling vial or bottle. You take it, you would have taken from the tap or somewhere. And the sewage water, wherever the stagnant water is there or running sewage water, you would have been taken like this and brought into the library analysis. Can you do like this air sampling? Because the air water pollution is finding out the water pollution. It is quite easier than doing the air quality analysis. Water quality analysis, water characteristics very simple than the air sampling. Only the point of sampling when we are considering both the case. Air sampling techniques are little complicated and getting ready of sample also is related. The thing is that what time we wanted to take the air sample. First, how will you take the sample? You are taking the water sample in the bottle or sampling vials. How will you take the air? And where you will take the air? And when you will take the air? Because suppose if I wanted to analyze the air pollution level based on the traffic or vehicular pollution in particular area of the city, how will do? The morning traffic is varied from afternoon, the afternoon traffic is varied from evening, the evening is varied, all the values are varied from night also. When the intensity is more also we do not know. And moreover, after 11 o'clock or 10 o'clock nowadays, the intensity of solar area photons are available more. Then the secondary pollutants started forming. Then what we cannot analyze. So when we can do the analysis, at what time we can do the analysis, how to do the analysis, or how to do the sampling, where to do the sampling, why we have to do the sampling. Everything we should know. So as of now, whatever I have told you, if you do the sampling in the morning, that only will give the idea about the pollution at particular place? No. Or if you do in the afternoon only, it is enough. And where you have to do the sample and how to do the sampling, there is also a procedure. And when you are doing this sampling, how you will come to know this particular place only, I have done the sampling. And if you, for example, you take the evening sample around 4 o'clock or 6 o'clock, and you are getting some X value. Can we fix that value that this is the pollutant level of that particular place? Whatever the value you get, that value may not be same in the morning and afternoon or night. Then how we'll report it? How we can do the sampling? There are many logic is there behind that air sampling and measurements. But whatever it may be, the simple concept based on the air sampling is we have to select the site and we have to do the sampling continuously over the period of 1 week to 15 days or 1 month. Throughout the day, 24 hours, we have to do the sampling. Then the sampling, how we can do the air sampling? You can think that we can use some observer. The air sample can be observed. Or you can use some tripping system like a solvent system. That solvent can solubilize the air pollutant. And it makes some complex form or matrix form. From the matrix, you can analyze. These are all idea anyone can have. And what chemical, what we can choose, and if we have some basic knowledge about the chemicals, then we can do like that. And how we can report? It's supposed to have, because today, today Saturday, tomorrow Sunday, Monday, every day the strength of vehicle or intensity of vehicle movement will be different. And whatever it may be, the pollutant is emitted, based on the wind velocity, it will be dispersed or diluted in the air. Isn't it? So from 1 day or 2 days or 3 days, and sometime it was raining means at that time the vehicle movement is more and there will not be any photochemical reaction also in air. And how we can give that report of air sampling? Sampling itself difficult. I said 2 methods, how many methods are 1 or 2 I said, and remaining I will see me meanwhile in the course of time. And when we, then in between many things are there, how you take the sampling, how you can analyze it. And when you are doing the analysis, what are the methods you have to adopt and how it has to be quantified. Whether the quantified or method of analysis is, it is competent or not, compliance or not. And whatever the method we have adopted, how it is. And in what unit you can express the quantity, and at last how to report it. That is very, very important, because if I say now today if I report Hyderabad pollution at a Secunderabad station is this milligram per meter cube, I will say Hyderabad pollution. Simply I say Hyderabad pollution, air pollution level in terms of sulfur dioxide, it is this much 550 milligram per meter cube. If I say, for example, don't take the value seriously. What does that mean? Then the question will come. When did you do the sampling? By what method you did the sampling? When did you do that sampling? Because what is that? They will ask what is the temperature, what is the pressure, what is the latitude, what is the wind velocity. Why these are all important? All meteorological parameters which are associated with the air pollution measurement is very, very important. Why? Because as I told you in the previous classes, as the air pollutant is released into the atmosphere, which is dispersed in air, that depends upon the latitude condition, pressure and temperature, and also the wind velocity, directional velocity, and also velocity value. So when you report particular pollutant level at the air pollutant at a particular place, you should know the name of the place. You should mention the name of the place. You should mention when the analysis is being done in that particular day. This much was the temperature, this much was the pressure, this much was the wind velocity, the latitude condition is on that particular duration, 1 day, 2 day, or weekday, or 15 days. This much was the variation of air pollutant. You cannot say confirmed value. This was that are in between from this and that milligram per meter cube of air you can report. We cannot say we cannot say in the sense it's difficult to say. There is a many factors involved. And otherwise you can say it is an average value or mean value. Either you have to give in the range or you can give in average. Exact value, if you give also, I don't think so it is valid. Clear? It is not valid also because n number of questions will come. On what basis you are telling? I can say I have done the study for a week time. Then you have to take it is the average of 7 days. Otherwise, I have done the study for a month, 30 days. Then you have to write it is an average of 30 months data. Like that only. You cannot say this much only is the pollutant at one particular value, a confirmed value or a whole value. It is very, very difficult to say. So, yet the quality of atmospheric air connected essentially with the level of pollutant due to the transmission and deposition phenomena and the secondary pollutant formation, as it is formed from the primary pollutant as well as from the environmental atmospheric constituents, can affect the state of the outer environmental area, mainly surface water, soil, everything. Therefore, we all know that it is very important to obtain and collect the versatile information on the type and quantity of pollutant that are present in air or introduced from the different emission sources. Yeah. How we can do this? There are different methods. Great number of methods are available, and analytical techniques are used to study the atmospheric air. Generally, the methods are classified based on the according to the according to some parameter. The parameters are, what are the compound type we are going to analyze, or the analyte compound, nature of compound, and its concentration level in the atmosphere or in the air, and measurement method, that is continuous method or it is periodical method. Period of investigation, it is long term or a short term investigation. Whether we are going to do the analysis in laboratory, in laboratory means in situ, and automation level measurement. And directly we can analyze the sample, we can do the sampling directly, or we have to use some analyte. I told you some of the solvent in that, they make it as a matrix, then bring into the laboratory for the analysis. Sampling mode and the type of appliance used for the sampling. These are all the factors to be considered or classified to find out or select the method or technique used to do the sampling or analysis of air pollutant. And also, 1 second, please. And also, what is the aim and task of atmospheric air analytics and the analytics and monitoring? Assessment of emission, assessment of pollutant emission, particularly, which is being used to find out the use of appropriate method and analytical technique used for air pollution area studies provides the information necessary for assessment of pollutant emission, particularly identification of emission sources, assessment of the interaction range of particular emitters, estimation of technical effectiveness of protective measures. And also it is being used to determination of ambient air pollutant and investigation of long-term trends in concentration changes, because periodically the changes will be there. For example, if any festival day, and if you are taking any holidays day, any other public holidays days, and the normal working days, and if any bunts are there, throughout the year, we cannot say 1 or 2 days per year, or sometime it comes. How all these days, the air pollutant level is being changed. And this changes in concentration, how it is reflected over the period of time in a long term. And study of the process in the atmosphere, that is transport and deposition of pollutant. Because as I told you that the pollutant can be transported from in the atmosphere. Around some of the pollutant will be transported more than 1,000 kilometers to 2,000 kilometers also. That's what the transboundary problem is coming. The place where the pollutant source is not there, they may also affect by the pollution problem because of this transport characteristics of the pollutant. And deposition means we know that the dry particle will be deposited on the building or any car or something, plant material, everywhere deposited. Once the rain comes, means that will be washed out. Those process has to be studied about the pollutant and the chemical, physiochemical, photochemical, biochemical conversion of pollutant, how it is converted from one form to another form by different form of chain reaction. And the estimation of exposure rate and accumulation of pollutant by living organism. That also need to be done. All these things we have to keep it in mind to do the study. Considering the analytical characteristics of instrument used for air pollution studies, that is in 2 types, devices can be distinguished. Analyzer instrument used in both in situ measurements and for the equipment of the mobile analytical laboratories, that is in situ or ex situ. For analysis, analyze all these things. What are the methodological demands needed? What are the technical demands needed? We should know. Because when we want to do the analysis, we have many ideas in our mind. That is whatever I have mentioned, those are all based on the what are the characteristics of pollutant, how it behaves. When we do the sampling, how we can do the sample without the change of nature of the substance. That is very important. Because now you want to find out what is the sulfur dioxide. that we know that when we exposed into the air, if suitable condition is come across in the atmosphere, then that will be converted into sulfuric acid. That is in the form of both dry and wet. So how many molecules of sulfur dioxide can be converted into sulfuric acid, that we can be quantified. That is okay, fine. But some of the things, some of the chemical we can quantify by theoretical assumptions or theoretical calculation. But some of them are formed by chain reaction, especially some of the organic pollutant or hydrocarbons, which are all formed in the atmosphere by sequence of chain reaction. And which form to what form it went, what form to which form we can, that is sequence. Some intermediate product we found, which we cannot say from where it formed, because there might be many sources. All the compounds we wanted to analyze means that is quite difficult, little complicated. That time we supposed to know what is the method we supposed to adapt. Suppose that now I want to do the benzene sampling, means there must be a specific method to collect the benzene. That benzene should not be changed in the benzene to some other form. It should be written in the same chemical form. Like that, we have to maintain. That means that whatever the nature of the pollutant we are collecting for while doing the sampling, till doing the measurement or analysis, the nature of the pollution supposed to be written as in the same compound. Then it is easier to quantify. If it does some chemical reaction, and one form to another form to this form, this is converting like that, but it is quite difficult to quantify. And what are the methodological demand and technical demand? These are all based on the whatever the prerequisite which we discussed earlier for sampling, that we must have an idea, then only we can have this demand aspects of consideration. When we do the air sampling, whatever the measurements we are doing or following, that's supposed to be highly sensitive method, and which is supposed to provide analytical information in continuous mode and in real time, or with only a slight time delay also it's okay. And it should provide the high resolution of results that are characterized by short response time and a long independent working time. Because 24 hours human beings supposed to sit there, then only the sampling can be done, means it is quite difficult. So independent working time must be important. That means automation of sampling. Some of the thing, not 24 hours. Then what are the technical demands needed for this? Because air sampling supposed to be carried out either morning to evening, or sometime for 24 hours also it's supposed to be done. The technical demands which depends upon, or it is being considered in the following aspects: automatic instrumentation, zeroing and calibration. Because when we wanted to do analysis, it was raining, we have to take out our sampler. Then you have to fit back again, means the calibration and zeroing will be changed. So then you want to do manually everything, it takes long time. So to avoid that delay and avoid to that interruption, that auto zeroing and auto calibration method, if you adopt, it will be helpful. And a safeguarding system against sudden breaks in power supply. If power supply has gone, I wanted to run the sampler for 1 week, 24 hours, but in between the power has gone, means what is the use of that study? And the power has gone today because of rain 24 hours, and then if something delay next day also 24 hours, power will not come in, then what is the use? In such a situation, any power breaks in it, there must be a supportive system to provide the power. Equipment of instrument in independent power supply, and the calibration model, system for filling and supplementing the working solution and reagent. There must be enough device protecting from the flame extinguisher, because we are running the sample in case 24 hours means any common place when you do the sampling, if anything happened at any time, if any burning or fire is happening, that must be protected protect the unit from the flaming or fire. Like that system must be provided. Then followed by this, what is the basic principle of sampling and analysis? Why we need to do this sampling and analysis? We have to think in deeply means the components of air pollution monitoring system include the main three aspects. The first aspect is collection or sampling of pollution both from the ambient air and from the specific sources. Second one is the analysis or measurement of the pollutant concentration. Third one is reporting and the use of the information collected. What is the third point mean? First two anyone can understand. Collection or sampling of pollutant from the ambient air or any point source, and analysis for measurement of the pollutant concentration at a particular place or particular location. And the third is we have to write the report based on the sampling and the analysis. And the very important and use of the information collected. So when we do the analysis, we will come to know that wherever the study made, there the pollutant level, whether it is exceeded the limit or within the limit, we are supposed to understand when we compare the standard level that may be derived by State Pollution Control Board or Central Pollution Control Board or WHO, whoever may be. Many people are doing nowadays, even NGO is also doing the same thing. When we do like this, then we should to know what is the pollutant level, then what kind of precautions or action can supposed to be taken. Whether it gives valid or not means definitely it gives 100% valid. For example, you take the place Delhi, and in 2000, 1998, 97, or we can say that 1995 to 2002, something like that we consider, up to 2000 when we consider, there the concentration of sulfur dioxide, particulate matter, even lead, benzene, many chemicals are beyond the limit only. When they come to know through this kind of measurement, the levels are exceeding the limit, and the people and the public is affected by this air pollutant too much through respiratory related diseases. And we can say asthma, tuberculosis, many diseases like that. Then they have shifted into from petroleum and petroleum byproduct into natural gas. That we all aware of it. I myself told in the class many times. In such a situation, the reports are really used. So the use of report is mainly for understanding or come to know the pollutant level or pollution level in a particular place, and how to protect that particular area from the overpollution. So either they may control the pollutant, or they by or through use that alternative, or by introducing new techniques, or by introducing the energy efficient method. Any one of the method people are following to us. Everything we will discuss, time is available today. And now we have collected the report. Then the emission data, whatever we have generated from the above study, either that is from the point source, or you collect the sample from the air, whatever it may be, that is supposed to be complies with air pollution regulations. And determine that is mainly useful to determine the effectiveness of air pollution control technology, and evaluate the production efficiency in any particular plant or a vehicle, whatever you are investing in anything, and which leads to support the scientific research. Suppose, for example, the people will come to know that this Delhi is polluted, too much polluted with sulfur dioxide. Now they have introduced CNG, compressed natural gas. They must know that by using of this petroleum and petroleum byproduct which pollutes our coal, whatever it may be, or fossil fuel, simply we'll say, which pollutes the air this much, what could be the alternative to replace that petroleum product or coal in Delhi to something else, that something else which should not produce that much pollutant. It must not be produced, it should not be produced any pollutant, or it should produce less pollutant. That idea we should know. That's what whatever the study we made, collection and sampling of air pollutant, and quantify the concentration of air pollutant, and reporting followed by the use of information, which is supposed to be which should be helpful to determine the compliance the air pollutant regulation, whatever they made it in India or somewhere else through pollution control boards, and which will be helpful to find out the effective method of production, and they can evaluate the production efficiency in the industry or anything, and which supports the research and development. Then only we can reduce the pollutant or improvise the method of energy conversion or whatever it may be. And the Environmental Protection Agency has established ambient monitoring methods for some of the criteria pollutant. For example, the organic and inorganic compound, those are highly toxic, like peroxyl acetyl nitrate, formaldehyde, like that. And inorganic substance, example, sulfuric acid, nitric acid, like that. These procedures regulate sampling, analysis, calibration of instruments and calculation of emissions. So this must be introduced: collection, analysis, calibration, and quantification or evaluation of emissions. The concentration, whatever they are quantified through this analytical method, it should be expressed in terms of microgram per meter cube. Microgram of substances or pollutant per meter cube of air sampled. Most frequently occurring pollutant in the urban environment are particulate matter, suspended particulate matter. You can see suspended particulate matter, respirable suspended particulate matter, carbon monoxide, hydrocarbon, sulfur dioxide, and nitrogen oxide, and ozone and photochemical oxidants. Photochemical oxidants are different. So from this figure, you can understand what is the source monitoring of air pollutant, what is the source pollutant and ambient pollutant. Source pollutant is being classified into line and point source, and ambient as per the WHO monitoring, they have given some of the components. The point sources are SOx, oxides of sulfur, oxides of nitrogen, carbon monoxide, and particulate matter. That is point source. But the line sources are similarly, carbon monoxide will be there, oxides of nitrogen will be the hydrocarbon, along with the respirable particulate matter. But ambient which are being the essential pollutants are sulfur, oxides of sulfur, oxides of nitrogen, and suspended particulate matter. The additional component which is based on the type of source and the type of source, in the sense either through the process or type of the material being used to release the pollutant, hydrocarbon, carbon monoxide, and ozone. And when we are doing the analysis of particular instrument that is called a stack sampler 622 APM, very important parameters supposed to be noted. Without these parameters, whatever the data we are generating, it won't give clear idea about a pollutant level at one particular point. That is, they are pollutant, velocity, temperature, and pressure of location where we are doing the sample. And some of the recommended criteria. Criteria. The recommended criteria for citing the monitoring station are as follows. First, we have to select the site, which is depending upon the use or purpose of the result which we are going to generate from the monitoring program. And the monitoring should be carried out with the purpose of compliance of air quality standards. Monitoring must be able to evaluate impact of new or existing air pollution sources Monitoring must be able to evaluate impact of hazardous due to the accidental release of some chemical like Bhopal gas tragedy. We think means suddenly when it is releases what is supposed to be, we should have in such an accidental solution how to protect or manage them. Otherwise, how it affected till date, people are suffering, the people for those who are living in and around that area. And monitoring data may be used for the further research purposes. All those things we suppose we keep very important or recommended criteria. We should keep it in mind to do the monitoring study. And when we are doing the study, how we have to select the site, do the sampling. That is very, very important. How we have to select the site. There are different types of site we can used, and each type there is a separate or identical description. Because when we are speaking or giving any modeling or method to tell about one particular place, we no need to describe about the, suppose now I am saying I have selected the area of Panjamutta for my study. On what basis we have to select? There are a particular classification how to select the site. If you select the site, how you have to use it and how you have to classify it. Under what classification which comes under, and how we can be reported. Because there are different analytical methods and standards are available for residential area, industrial area, and also commercial area, agricultural area. Last class we have seen when we discussed about the laws and policies of air pollution standards. In that lesson, it must be, we know that there is a separate standard for specific standards for residential area, commercial area, industrial area, and rural area. So when we want to do some analysis in a city or urban area or industrial area, that cannot be compared with the rural area. So the site selection, which comes under what type we should know. There are six different types of station, which was standardized form of source to be identified. Based on that, we have to record it. For example, if there are types in type A, type B, type C, type D, type E, type F. For each type, they have description. For example, type A, only one I will explain. Further, you people go through, you can understand. Type A, about that I wanted to speak means downtown pedestrian way, the average traffic level must be more than 10,000 vehicles per day. More than 10,000 vehicles per day. In such a situation, yes, per day, and the location estimation supposed to be 0.5 meters up to from curve, from curve, and the height supposed to be 2.5 to 3.5 meters from the ground. And those location 10,000 vehicles per day means it must be the busiest area, isn't it? It may be business district or congested area surrounded by the building, and many pedestrians must be going and all that kind of area only. And if you take the type B means, yeah, the average vehicle flow must be more than 500 per day. In such a situation, when we'll think what could be the area, it may not be congested, we can say, and less high-rise building, we can say. It may be business area, business district, but the location like a park, mall, landscape area, those are all comes under this category. Here also, the location of station supposed to be around 0.5 meter from curve, and the height supposed to be 2.5 to 3.5 meter from the ground. And the type C is residential population exposure station. This is a residential area. It could be suburban area and not in the central business places or districts. Like that, each and every type, type A, type A, type C, type D, E, F, everything is having their own description about the location or state. And each places the standard values or a specific standard each state has. We have to compare, then only we can write this particular place is highly polluted or not. And now I'm asking that no one is there to interact. How I'm speaking by my own always. People can respond also. No one is responding. How it could be continued quite a long time. People are there, you have to respond, and then only the class will go alive. Okay. But once we select the site and the general frequency of data collection that is to be followed by gaseous pollutant continuous monitoring for the particulate is once every 3 days. And the number of stations are minimum number of stations supposed to be 3 for the comparison. The location then is dependent upon the windrows diagram, and that gives predominant wind direction and the speed. Because when we are not getting something, it will not be dispersed out. That is very, very important. One station must be upstream of predominant and the direct wind direction, and the another 2 must be downstream predominant wind direction. More than 3 stations also can be used, but minimum supposed to be 3, which is depending upon the area of coverage. Suppose now I said minimum means for entire Hyderabad, if I select 3, it is not good. Okay, because this is huge area. So when we combine with the small area, minimum supposed to be 3. Suppose if I will say I want to do the analysis nearby railway station, Secunderabad railway station, there 3, 4 is enough. For the entire Hyderabad, it should be manifold like that. 4 main component of this air samples are air sampling devices, which include inlet manifold, air movement device, and collection medium, and the flow measurement devices. Because we should know what is the velocity of air. We must know on what medium we are collecting the sample. That should not be reactive with the pollutant. And air supposed to be moved from the source to the collection medium, and where there must be a provision to enter the air pollutant into the unit. And inlet manifold transport sample pollutant from ambient air to the collection medium or analytical device is an unaltered condition. That is very, very important. When we are handling this, the pollutant is transported from the air to the collection medium. It should not be altered the condition. Then manifold should not be very long. When it goes from source to the collection media very long, when there must be a loss or something, and it is energy point of view, wastage of power. So we should not be very long. The collection medium or anything, it could be liquid also, or it could be solid sorbent also, or sometimes it could be used as dissolving gases also, or sometimes filters, or samples for air analysis, that is automatic instruments. The flow device like rotameter must be used to find out what is how much volume of air is used for this sampling. And 5 main characteristics for the air sampling system are collection efficiency, sample stability, recovery, minimal interferences, and understanding of mechanism of collection. If we are not understanding how we will do that, because now whatever method we are talking, this is not analysis, this is only collection of sample. Collection of sample, we have to make this much precautionary action, and we supposed to be provided with this kind of technical facilities. Then only we do. So whatever it may be, and at the end of the things, you should be having the good collection efficiency, and you should retain the stability of the material. And it should not be having any interference with the outside meteorological parameter or anything else. And we have to understand the entire mechanism, whatever we are followed for the sampling and the recovery at last. The first 3 must be 100% efficient. That is, what is the first 3? That is collection efficiency, sample stability, and recovery. It should be 100% efficient. For example, when we collect the sulfur dioxide, the sorbent should be such that the ambient temperature, it may remove the SO2 from the ambient atmosphere 100%. Otherwise, sample must be stable during the time between sampling analysis, recovery. The analysis of particular pollutant must be 100% correct. Otherwise, whatever the technique, this it is not that much, it is a tedious process and a laborious process. And we have to put up our effort for 24 hours. In such a situation, if you are collecting and doing analysis at the end of the method has error, means no use. So whatever the method we are following, it should be 100%, must be or should be correct. The basic concentration of sampling, which include sample must be, sorry, I didn't change this. Okay, we'll wait that, we'll see. The sampling must be represented in terms of time. I told you at what time we have collected and what location and what condition to be studied. That means what the time means from morning 6 to evening 6, or we can say 24 hours. And the location means exactly where the place, because there are different types of place. One is a business area, another one marketing area, both are same. Another one is residential area, industrial area. So what type of location we have to specify in the report, and the condition, what is the temperature, pressure, wind flow, whether it is rain, or all the meteorological parameter is supposed to be mentioned in that. These are all the information must be provided during the sampling and when we are giving the sample for analysis. Sample must be large enough, because when you are doing this kind of analysis, there must be enough human power used, electrical power used, chemical energy is used, many things in terms of instrumentation and the cost, everything all together, many things will come into the picture. So when we are collecting, the sample is supposed to be enough, because when we are doing the analysis, something happened, we have to repeat again. So already we have sample, the analysis can be repeated. But for sampling itself, it gives very less and the study must be wasted. So it should be provided enough quantity of sample. And the sampling, when we are doing, the sampling rate must be such as should not be provide the maximum efficiency of collection, and the duration of selection must be accurately reflect the fluctuation in pollutant level, because where 1 hour, it must be, if you do the analysis at that time, the vehicle movement is more. Sometimes the vehicle movement is not. But when we cross the road, we can understand. No? Sometimes we can easily cross. Sometimes we have to wait for 10 times. That much traffic will be there. So how frequently when we are doing the analysis and reporting it, whether it is a 1 hourly, 4 hourly, 6 hourly, 8 hourly, 12 hourly sampling, when we are doing, how it does the difference is the changes are occurring, we can find out, or we can say in terms of how the fluctuation it could be. Continuous sampling is preferred. Pollutant must not be altered or modified during collection. That is already I have mentioned in the name. Then WHO highlights for air quality. What they are telling, the pollutant they have for different pollutant, the average time and AQG value they have given. That means air quality value. Particulate matter, that there are two types of particulate matters, PM 2.5 and PM 10, we know that. And for PM 10, 1 year, 24 or 99th percentile, the value must be 20 microgram cubic per meter and 25 microgram cubic per meter. And 1 year, 24 hours, 99th percentage also given. And PM 10 also is followed with the same average time, but the value is varied from 20 microgram to 50 microgram per cubic meter of gas or meter cube of gas. Ozone level, 8 hours sampling, the daily maximum they have considered, that is 100 microgram per cubic meter of air or meter cube of air. Nitrogen dioxide, 1 year, 1 hour, which varied from 40 to 200 microgram per meter cube of air. And sulfur dioxide is varied from 24 hours to 10 minutes, which varies from 20 microgram per meter cube to 500 microgram. Then we can understand all the values. Everything is high only. None of the values are less. Only particulate matter is less. I don't know how they have made it still. And USPA, that is United States Environmental Protection Agency, in 2006 National Ambient Quality Standard they have derived. That particular type, primary standards, and average time, secondary standards. You just to go through it and find out how the variation is there. This and all, you people can just understand when you see. And about that paragraph, they have an interference, how the values would be changed. Now we'll discuss about how we'll do the sampling. I told you there are different methods. And observer must be used. They can use any solid, liquid or gaseous medium for observing the gaseous sample. And one more, filters also people are using. And stack sampler and Imbinger bottles, cross-section of sampling, the Imbinger bottle, these are all the very common things. People are adapted for doing the sampling. And how the method is being used. Stack sampler means whatever the method I have discussed now. The system supposed to have inlet device and air movement, collection medium. And after collection medium, it entered into the measurement device. And inlet manifold transport the sample from the air into the collection medium. The collection medium should be, and collection medium should not be alter the sample condition, I told. And this device forced to create the vacuum and lower pressure at the one end, so the sample is being moved from a inlet to the collection medium easily. There we have to create the vacuum, then it is easily suck the air with pollutant from the atmosphere, then it goes to the collection medium, sucking and releasing by different pressure difference. Under vacuum, it is sucked, and at the end of the unit, the pressure will be, which is not in vacuum, so it is easily comes out. And the flow device, like a rotameter, is being used to find out what is the volume of, how much volume of air is sucked for this sampling. And the main characteristic ambient air sampling system is collection efficiency, sample stability, recovery. These are all we have discussed, isn't it? Recovery, minimal interference, and understanding of mechanism used. All these concepts basically used for the stack sampling. Stack sampling is a kind of device where the people are using the filter paper as a collection medium. When we are sucking the air from the atmosphere through the inlet manifold, that is, they are providing the vacuum. Under the vacuum, it is sucked and it is collected into the filter paper. Then the filter paper is being collected. It bring into the laboratory. They are doing the analysis. Make use of the filter paper. By weight difference, they can understand what is the total pollutant level in terms of weight. Then individual pollutant level will be identified by digestion of that filter paper with a triple acid. Then they will follow different method for different pollutant for quantification of particular pollutant. That we will see in the next session. Then the next one is the various parts of the sampling. And another one is Imbinger bottle. Do you know what is meant by Imbinger bottle? Anyone can, no one is there in the class. I myself talking, this is also something different only. Hello? 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 Anyone is there? Hello? Imbinger bottle means it's a kind of bottle which has two mouths must be there. One is at the top and another open is at the side. When we wanted to separate liquid and gas, or soluble gas and insoluble gas, through the collection medium, some solvent must be presented in the bottle. Imbinger bottle, which looks like a round bottom flask, which has two mouths. The inlet of, there is one inlet and one outlet. Through the inlet, the sample is entered into the solvent. And the sample is collected and dissolved in the solvent or water which is presented in the bottle. And the remaining insoluble gases exit from the first bottle, and similarly, Similar kind of bottle are arranged in a sequence, 4 or 5 bottles, and those bottles are arranged in a cool and medium, either ice or ice bath or water bath like that, because all these gaseous pollutant mostly which released at the little higher temperature only. So some of the chemicals will be highly volatile. If those volatile matter may be escaped, so for that only they are providing the sequence of imbinger bottle. If it is not dissolved in one bottle, in another bottle it may be dissolved due to the temperature difference. Like that, the arrangement is being made. Here, the most important in the imbinger, which lodges the sampling solution, or we can say solvent or water, and imbinger or glass bubble tubes designed for the collection of airborne particles into a liquid medium. When using an air sample, a known volume of air bubbles are pumped through the glass tube that contains a liquid specified in the method. The liquid is then analyzed to determine the air particle. So the whatever the liquid, when it entered into the first bottle, which is dissolved in the solvent, and the remaining is entered through the outlet to the next bottle. And in that collection medium, some of the things are being collected. And the remaining will be exit, and it is entering into the third bottle. And some of the pollutant will be collected or particles collected in the third bottle. Something may be exit from the third, then it is collected in the fourth. Like that, it is connected in a sequence, and the entire setup is kept it in the or keep it in the ice bath or cooling water supply system. Then after the study is over, we have to collect the solution from each bottle and you mix all together. Then you take this into a laboratory for the quantification of particular pollutant. This is imbinger water. Okay. It is very wonderful. Even if you do any reaction, any volatile chemicals are coming out. If you wanted to quantify the carbon, qualitative and quantitative study, both you can make by following this imbinger bottles concept. It is very wonderful. We can come to know to some extent, and sometimes it is possible to give accurate answer also. And it is adaptable technology to quantify any gaseous pollutant or gaseous mixture released from any chemical process, not only the for pollutant analysis. Okay. And monitoring of air pollutant we'll discuss now. monitoring of monitoring of pollutant. Then particulate monitoring and gaseous pollutant monitoring. Particulate monitoring usually accompanied with manual measurement and a subsequent laboratory analysis. Particulate matter means we cannot use any sort of sensitive instrumentation, GC, EMS, HPLC, chemiluminescence, spectrophotometry, many methods are available. It is not required. So it is manual measurement followed by laboratory analysis. We can quantify that. And particulate matter in measurement use gravimetric principle. So gravimetric analysis refers to the quantitative chemical analysis, weighing of sample, usually of a separated dried precipitation. Okay, so this is not very complicated method. It is very simple method only to be adopted, and we will come to know the concentration of particulate matter. Okay. The thing is, in a gravimetric analysis, quantitative chemical analysis of weighing of sample, usually of a separated and dried precipitation. But in this method, a filter-based high volume sampler, whatever we have discussed, that is vacuum-based, we discussed now, that one. A vacuum type device that draws air through filter or absorbing retains atmospheric filter for future laboratory by chemical analysis or weighing, that is wet analysis or gravimetric analysis. The particles are trapped or collected on filters, and the filters are weighed to determine the volume of the pollutant. The weight of the filter with the collected pollutant minus the weight of the clean filter gives the amount of particulate matter in a given volume of air we can. Okay. And the particulate sampling, actually it is not in the sequence, it is zigzag manner it became. When we are doing this study, the principal basis of air pollution law in US, which depends on air quality standard philosophy, is to have air safe to breathe. The purpose of that study is air supposed to be safe to breathe for living things. This means that the air quality should meet the national ambient air quality standard. To achieve that, control the monitoring of air pollutant should be implemented to control pollutant concentration, and the time, the place, and the amount of emission should be regulated. The emission rates of various sources of air pollution must be regulated and measured. And also, why this measurement is legal? The need of this measurement is for legal requirements, evaluation of air pollution control devices, or implementation of any control devices. The control devices should be brought with guarantee, and with final payment should be after demonstration that the device is installed, calibrated in good performance situation or not. After all those studies only it should be published. And the aim of sampling must be the principal requirement of sampling systems to obtain sample that represents the atmosphere at a particular place and time that can be evaluated as a mass or volume concentration. That means milligram per meter cube or this much meter cube per meter cube, something like that. The sampling system should not alter the chemical or physical characteristics of sample in an undesirable manner. This is very important because if it changes means any quantification we made it also, it will not at all be helpful. Isn't it? Okay. Then particulate matter analysis sampling, I said. The particular sampling, I said it could be done by the vacuum high volume sampler. High volume sampler that works under vacuum type, I said. and they are using any filter absorbent which absorb the material, and we have to collect the filter paper or absorbent into the laboratory. And based on the gravimetric analysis, that is, you have to weigh the filter paper. Because when we put the filter paper, when you are running that sampler at vacuum, it is collected and it is sucked and absorbed, or it is the particles are trapped in the filter paper or filters. And we can weigh the, we will come to know the concentration of particulate matter by weighing the filter paper. That will be the weight of the filter paper with the pollutant, and the fresh filter paper weight. The difference between these two gives how much particulate matter is being collected during that particular duration of time in that particular place, and what are the meteorological parameters. Everything we have to be given, and that will be reported in the form of this much gram of particulate matter presented in the given volume of air we have to be reported, because there is a flow meter which gives volume of air passed into the filter paper. We will come to know by make use of rotameter. Okay. The next one is gaseous pollutant monitoring. We have discussed only particulate matter monitoring. Now we are going to talk about the gaseous pollutant monitoring. There are different methods are available to monitor the gaseous pollutant, and using various measurement principles. Some of the most common technique is to analyze the greenhouse gaseous pollutants include spectrophotometry, gas chromatography with the flame ionization detector, gas chromatography with mass spectrometry, and chemiluminescence method, Fourier transform in FTR, Fourier transform infrared spectrometry. These are all very common methods are being adopted for analysis or quantification of this gaseous pollutant. But whatever the method we are using at the end, with all sampling and analysis procedure, the end result is quantitative data, because qualitative data will give an idea. Quantitative data which gives or provides the information what we supposed to do further research or further action on a particular area or a particular pollutant. So the validity of the data depends upon the accuracy and precision of the method we adopted to generate the data, and the primary quality control measures and calibration. Calibration checks the accuracy of measurement by establishing by relationship between the output of measurement process and the known input. When we are, suppose for example, we are using GCA, GCMS, gas chromatography, mass spectra, gas chromatography, flame ionization detector method, chemiluminescence spectrometry, and FTR, whatever the method, the accuracy is based on the calibration. What is meant by calibration? Suppose known all these methods are used to quantify the unknown substances, unknown quantity of substances. But this substance we know, sulfur dioxide we are going to analyze, we know, but how much sulfur dioxide is there we wanted to find out. So it's just for quantification. For that, any instruments it's supposed to be satisfy the calibration. When we follow the calibration, how we have to do? You have to analyze the known concentration of sample. When we do the analysis with the known concentration of it should give the exact concentration. Then only whatever the method you have adopted is correct. Otherwise, you have to change the method of analysis till you get the exact amount of known quantity of sample, known concentration of sample. Make use of that relationship. That means known input. When we are giving input, in that 10 microgram is there means you have to get the output with the same 10 microgram of liter cube. If you get, then your calibration is correct, then you can follow the method for unknown quantification. That the calibration is very, very important. Without doing the analysis, you get some result also, it is not valid and it won't be correct also. And chemical analysis can be done by atomic absorption spectrometry, atomic fluorescence spectrometry, AAS, AFS, and in ICP, inductively coupled plasma, inductively ICP spectrometry, and X-ray fluorescence, XRF, And some of the summary of this method, what kind of pollutant we can use and what is the pollutant and what is the principle involved of this analysis, we'll see. Suppose gravimetric analysis. Now only we have seen gravimetric method is used to find out the particulate matter analysis, PM10 and PM25, 2.5. The principle involved in this particular method, this is very important. If you know well about this, then you can write the further things by your own. Okay. The basic principle involved in this gravimetric method of analysis is the particles are pollutant, particle matters are trapped or collected on filters, and then the filters are weighed to determine the volume of pollutant. And the AA is atomic absorption spectra is being used to identify or quantify more than 60 metals or metalloid elements, including lead, mercury, zinc, all heavy metals also. This technique operates by measuring energy level difference at the atomic level of the element. And emitter radiation is a function of atom present in the sample. And spectrophotometry, this is used to find out the concentration of sulfur dioxide and ozone. This is very common method you would have done in your practical classes. Measure the ambient light that a sample observes. How much light is, measure the amount of light that observed in the sample. The amount of light observed, which indicates the amount of analyte or the pollutant present in the sample. And the last one is chemiluminescence, which is also useful to find out the sulfur dioxide and oxide, like ozone. The principle based on this method is the emission spectrum of an excited species that is formed in the course of a chemical reaction. Chemiluminescence, the chemical reaction is taking place. When the reaction is taking place, which gives the emission spectrum, and that emission spectrum of excited species, when the reaction is happening, some of the species might be excited. Those excited species emission spectra, how is it? So based on that principle, SO2 and O3 quantification is taking place. Gas chromatography, which uses different type of detector. One of the detector is flame ionization detector, which is useful to find out the gaseous component, specifically volatile organic compound, which responds proportion to the number of carbon atom in gases. This is also based on the absorption desorption phenomena, and which indicates based on the number of carbon in the gaseous sample. And gas chromatography mass spectrometry, GCMS. This method is based on the difference in mass to charge, Ember Z, mass to charge ratio of ionized atom or molecule to separate them from each other. This mass spectrometry, what it does, which break down the material into the small fraction based on the atomic weight. Then that each atom which generate the charge, then it is being considered as a M/Z, mass to charge ratio. And each atom gives the same thing in ionized stage or ionized atom or molecules, and separate them based on the ratio separately. Each ratio component which reflects the peaks, based on that we can identify what kind of molecules, and quantification also can be done based on the same way. And Fourier transform infrared spectroscopy, it is being used to quantify carbon monoxide and volatile carbon and methane concentration. Sample absorbs here infrared radiation, and the difference in absorption is being measured. This Fourier transform infrared spectroscopy and the spectrophotometry, both are similar, but here it is working in the light range of infrared. There they are using visible range. That is only the difference. Both are working in the same principle, remaining concepts. The leftover topic we will see in the next class. Now we'll wind up. The next class will be started by 3:15. Okay.